Okay, let's say we have a surface. Example of a two-dimensional problems. So we have two objects on the surface, and we have assuming that we have a light pulley. When they say light pulley is, we ignore the mass. It's massless. Let me bring it down a bit. Okay, and then this one hanging another mass, which should be heavier, like this. Now we have a system here, three bodies. Okay, let's say this is 3 kg, this is 2 kg, and this is 20. Now we want to find, the question asks you to find the tension, and also find the acceleration of the system. Okay, so this is the question. How do we solve it? Now, our final answer is the tension and the acceleration. First, let's understand the acceleration first. If we have a system that is connected like this, okay, connected by strings, when this object accelerate this much, all this object is going to accelerate the same, okay, because they are connected system. Okay, and if you think of the overall motion, where is it going? It should be coming down like this, right? Because you have a heavier weight here. So this object is accelerating downward, and these two objects on the surface, they are accelerating to the right. Okay, so first let's make clear of that one. Acceleration is the same for every single body. Okay, now, and then we look at the tension. If you remember in the last lesson, I said that the tension is the same for the same string. If you are looking at the same string, then they have the same tension. Different strings, they have different tension. How many strings we have here? We have one from here, run over the pulley, connected to the 20 kilogram, right? And then we have a second string between the 3 kg and the 2 kg. So we have two strings here, two different tensions. How do you label tension? Out of the object. Okay, let's call this tension 1, T1. And again, I label another one coming out of this object here, T1. Same, huh? And also you can do like this, also coming out of the pulley, T1, T1. Okay, but it's actually the same as, if you don't label, also can, right? So it's always we label inward, inward. What about this one here? This one, again, coming out of this body and coming out of this body. So T2, T2. Okay. Now, what about other forces? Now, step one, always you want to label everything, all the forces on the diagram. Okay. So we have reaction, and then we have mg. Now I'll just use 10 as my gravitation acceleration, easier. So 20 here, and this is 30. Okay, and then again we have mg here. This is 200. Is it all the forces? What is our list? Okay, F equals to MA, mg. This one already. F, TR. Tension already, reaction already, the friction. Okay, sometimes the question gives friction. Sometimes the question says assuming there's no friction. Okay, now let's say we have a friction, and the friction of the 3 kg mass is 5 Newton, and the friction of the 2 kg is 3 Newton. Now, label the friction also on the surface here. This is 5, and this is 3 Newton. Okay, so after we label everything, then we start finding, okay, acceleration and tension. Let's find the acceleration first. To find the acceleration, There are two methods. I'm going to show you the two methods. Okay. Sometimes you'll find method 1 is easier. Sometimes you'll find method 2 is easier. I'm just going to show you two so that you can pick which one is you like the best. Okay. And sometimes it depends on the question also. Some question method 1 is easier. Some question method 2 is easier. Okay. So let's look at method 1 first. Method 1. Method 1 is using free body diagram. Okay. Now, how many body we have from this system? 3, right? We have 3 bodies. So that means you're going to have 3 free body diagrams. Yeah. So let's draw the first one. So we have 3 kg. When drawing free body diagram, you only look at that body and the forces acting on that body. Make sure you label every forces acting on that body. So 3 kg, we have R, we have mg, okay? And then we have, to the right is what? This one, right? T2. We just take one side, T2. And then we have, this one is 5 Newton. Okay, you can see we got horizontal forces, we got vertical forces, right? Now, where is the acceleration? For this body, the acceleration is towards the right. Applying the Newton's second law, if acceleration is towards the right, that means my resultant force is towards the right. So T2 has to be greater than 5 Newton. We don't look at the R and the mg. Why? Because you see the acceleration is going to the right, right? That means vertically acceleration is 0. So this and this one has to be balanced. No acceleration in vertical. Okay, so only horizontal acceleration, T2 bigger than bigger than 5 Newton. So I will write F equals ma. T2 minus 5 equals to ma. Okay, then I just put in the value lah. T2 minus 5 equals to 3a. That becomes my equation 1. I have an unknown, the tension and the acceleration. Okay, free body diagram number 2. Here, I draw the 2 kg. Okay, so we have R, mg, T1, and on the left, T2. Okay, where is acceleration? Acceleration again is to the right. So R balanced by mg, T1 bigger than T2. F equals ma. T1 minus T2. Now, I left out one thing, which is the 3 Newton resistance, right? Okay, so let me add it in my diagram. Over here, you have another 3 Newton. Okay, so the 3 Newton also have to include. So T1 minus T2 and minus the 3 Newton equals to ma. But the mass, okay, I just put 2 in, 2a. That becomes my equation number 2. Yeah, so T1 and T2, they are 2 different values because they are different strings. Okay, number 3, the third free body diagram. 20 kg forces T1, mg. Where is acceleration? Downward for this one, right? So F ma mg minus T1 equals to ma. So for each free body diagram, you derive the equation of motions. Okay, that is why this is in your previous lesson, right? We learned to write the equations of motion. So mg minus T1 equals to ma. Right, so T1 equals to mg minus ma, and I'll just put it T1 equals to mg minus a, T1 is 20, 10 minus a. And this become my equation 3. Okay, once I have all 3 equations, then I solve it. Find the acceleration. Okay, find the acceleration. So we are going to use equation 2. That means I'm going to substitute equation 1 and 3 into equation 2. Okay, so this T2 I put it here, T1 I put it here, so that everything become only one unknown. Okay, so 20, 10 minus a minus T2 is 3a plus 5 minus 3 equals to 2a. Okay, and then this one, 200 minus 20a minus 3a minus 5 minus 3, 2a. Okay, so we just do some rearrangement. We get 192 equals to 25a, and acceleration equals to 7.68 meter per second square. Okay, now once I have the acceleration, that means this one accelerate at 7.68, this one 7.68, this one 7.68. Then we find the tension. Already got A, then you substitute the A into equation 1. So T2 equals to 3A plus 5. That's 3, 7.68 plus 5. 28.04 Newton. And T1 equals to 20, 10 minus 7.68. 46.4 Newton. Okay, so this is solving using method 1, which is drawing the free body diagram of each body. And then you just solve it simultaneously. Okay, what about method 2? Alternatively, you can solve this one, which is we look at these systems as a whole instead of looking at one body, one body, one body. Okay, so that means this system, I can imagine it like this. 3 kg, 3 kg, and then 2 kg. And then connect to this one, 20 kg. What I'm doing here is like, I imagine that I remove the pulley. Okay, I remove this pulley and then I straighten the string. Okay, you can imagine that this entire motion, if I straighten it out like this, because this is going down from here and this is going to the right, right? So if you straighten out like this, then this whole system would be moving to the right. Okay, okay, this 3 kg, 2 kg, 20 kg, they are all moving to the right. Now, what about the forces? Same, you keep this one. R20, this one, again, R30. What about the 20 kg? Initially, T1 is pointing up and the 200 is downward, right? When you straighten it, now T1 is pointing where? Now T1 is pointing to the left. So we have T1 here. What about the mg? The mg initially is downward. If you put it up here, then the mg would be now to the right. Okay, complete the forces. T1 here coming out of this object, we have another coming out of this object, same string, so T1, same. Second string, this one, T2, coming out, T2. What about the friction? Okay, the three friction is oppose the motion, right? Oppose the motion. So if the overall system is moving to the right, then the 5 Newton must be to the left. Okay, and the 2 kilogram, again, we label one more force, 3 Newton to the left. Okay, so we are looking the system as a whole. Okay, from here, you can cancel this one and this one because you can see the forces is towards each other. So you can just cancel out like this. The T2, again, you can cancel. So no more tension. We don't need to care about the tension in this case. So left, what forces? We got the reaction, the mg, but those are the vertical forces. Again, we don't need to care about it. We only look at the horizontal. Why? Because your acceleration is horizontal. Okay, right. So what are the horizontal forces? Mg, the 3n, and the 5n. Other forces are irrelevant. So I'm going to use F equals to ma. The resultant force. What is the resultant force of this system? Mg minus 5 minus 3 equals to, now you have to be careful with the m. This m is the mass of the whole system because now you're looking at what whole system, right? So it's the mass of everything. 20 plus 3 plus 2. 20 plus 3 plus 2. Acceleration A. Okay, so all this value you know already. So 20, this mg, okay, so 200 minus 5 minus 3 equals to 25A. 192 equals 25A, and A equals to 192 divided by 25. 7.68 meter second square. Which one faster? Method 2 is faster, yes. But this is only to find acceleration. If the question asks you to find tension, you need the free body diagram. Okay, so that means either you use method 2 to find the acceleration and then you draw the free body diagram just to find the tension, or you can straight away use method 1. Okay, because after you get the acceleration from method 2, to find the tension, you're going to draw the free body diagram as well to find the tension. This one just makes it easier to find the acceleration. Okay, so here's an example of solving two-dimensional problems. Right, I give you 1 to 2 minutes. You can take some notes, jot some important stuff, and we will go to the second example. Now, one thing, there's an assumption that we do for this kind of calculation. Sometimes maybe the question they will ask, what is the assumption made when you calculate, when you do the calculation? First assumption is that the pulley is massless, right? Because if the pulley has mass, that is going to have forces on the system as well. It's going to affect the overall acceleration and tension. So we assume that pulley is massless. Number 2 is that we assume that the pulley is frictionless. Okay, pulley is frictionless. If normally the question, they won't give friction at the pulley. right? But if there's friction, then what do you do? If there's friction at the pulley, it's the same thing. You do method 2. Let's say there's a friction of 3 Newton at the pulley. Then you just add one more force, 3 Newton. For method 2, right? The string here, you just add one more force, 3 Newton. Where should it be pointing? It should be pointing to the left, because the whole system is moving to the right and friction is opposite to it. Right? So this 3 Newton is the friction at the pulley. So you just add one more force inside here, then your acceleration will be different. Okay, so if question says the pulley is frictionless, then just skip it. No need to care about the friction at the pulley. Right? Number 3, we are going to assume that the string, the string is again massless, okay, or weightless. The string is weightless. We ignore the string, the mass of the string. Okay, so we use light strings. 3 assumptions when doing this Newton's law calculation. Right. 1 minute. And we go to the example 2. Okay, we go to the next one. And the second one, the second example, you try it yourself. Okay, I'll give you 3 minutes. Try it. If you have answers, you can type it in the chat. Okay, finished? Any answers? Hmm, haven't? You done, ma, haven't? Haven't, you there? Naomi, any answers? Or still doing? Okay, still doing. How about the rest? Jonathan, you have answers? Still doing, okay. Okay, everybody's still doing. Okay, right. A few more minutes. Okay, we look at the answers. Huh? You check your answers. Okay, label forces R and G. We put this as tension 1, tension 2, mg, mg. Okay, so find acceleration first. Where is the system moving? This one is heavier, right? So it's moving down from here. This one going to the right. This one going up. Now, imagine I stretch out. So we have 10 kilogram, 3 kg. Okay, so I stretch out, and the forces, the mg become here. This is T1, T1, R, mg, T2, T2, and then we have this one, mg over here. Okay, so the entire system is moving to the right. Okay, because it's the mg. This mg is pulling it. Okay, the irrelevant forces we cut off. Cancel, 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 cancel. This is vertical, no need to see, no need to see. So only this mg and that mg. This mg is 30 Newton. This mg is 10 Newton. So you use FMA 30 minus 10. Mass is the total mass. So 14, okay, 10 plus 3 plus 1, acceleration. (20) equals to 14 acceleration. So A equals to 1.43 minus 2. Okay, how about tension? So tension, you need to draw the free body diagram. So we have, you can draw any one. Okay, I'll just pick this one because there's just one unknown, right? T2, and I pick this one. So FBD for the first one, 1 kg, T2, acceleration is going up, but now you already know the value, right? So acceleration is 1.43. Now using the, this one is like in one dimension, forces in one dimension. So using FMA again, resultant is upward. So T2 minus mg equals to ma. Okay, T2 equals to ma plus mg, 1.43 plus 1 and 10. 11.43。 Okay, so acceleration downward, resultant force downward, mg minus T1 ma. T1 equals to mg minus ma. .71 Newton. Okay, that is your answers.